Okay, let's talk about t-test. T-distribution is a distribution of uh, a set of IIDs with with normal distribution that has a mu and sigma of a of a distribution. So we can normalize it by sum all of them together and divide by sample size minus population mean and divided by sample standard deviation. And then the degrees of freedom of this distribution, the D, is defined as n minus 1, where n is a sample size. So we can, for the purpose of this t-test, we pretty much verify the null hypothesis of data 1 and 2 have the same mean, where the data set 1 has mean of x1, variance of s1 squared, degrees of freedom is n1 minus 1. Same for data set similar to data set 2. So we have a pooled variance, put standard deviation, calculate as such, and then the variance of those two mean minus subtract each other will be represented as such. Thus, we can just plug the square root of variance, which is standard deviation down here, and then since the null hypothesis is they're the same, meaning the mu square. So sorry, mu hat is 0. So here is 0. And we know the degree of freedom is n1 plus n2 minus 2. We're going to check back to the table of t distribution as where the alpha is 0.05, which is 95% confident. And z-test is it's just relatively easy to explain. The z-test is just a t-test with d greater than 40. So to illustrate further, the t distribution is with degrees of freedom of 1 is this, degrees of freedom of 4, degrees of freedom 40, where the blue line is the normal distribution. As you can see, the degrees of like if it's 41 data point, we will already have a t distribution almost exactly trace the normal distribution.